In our last example, we made an estimate about a population parameter based off of one sample that Seth did. So we've got Tia joining the conversation here. Tia is contributing to the same project as Seth and has sampled a different group of students. The proportion of freshmen in her sample is 0.4 or 40%. So if we just kind of look at her data, this is what she has collected. She's got freshmen, 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 ooh, a lot more. Freshmen, so if we count those up, that's 1, 2, 3, 4, 5, 6, 7, 8. So she had 8 freshmen out of her total 20 participants, which gave her that 0.4. or 40%. Seth's results were 0.2 or 20%. So how can Seth and Tia determine whose result is a better representation of the population? I mean, they got pretty different results, either 20% of your population are freshmen or 40%. How do we know? So essentially, they need more samples. Right now they have 2. They have Seth's sample of 20 students. They have Tia's sample of 20 students. They need more to get a better picture of the population. So what they do is they get 50 more samples. They are busy. So each sample has 20 students, and then they're getting the data from each sample. So they took their 50 more samples, and then they compiled all of those samples into a histogram, and that's what this picture is right here. So this example is called Make an Inference Using Multiple Samples. So this is a histogram of multiple samples. Remember, each sample we're asking 20 students what year they are in college and how far away they live from home, or how far away their hometown is because they're away at college. Just to make sense of what this is, so right here, if we follow this straight across, we have 6 samples. So in 6 samples out of 50 total samples, between 30 and 35% of the sample participants are freshmen. So here's 30%, here's 35%. So between 30 and 35% of the sample participants are freshmen. We also can look at the Instagram, the histogram, and make note of where most of the samples fall. So if we look at this part right here, remember this is 50 samples. We've got 2 samples here. We have 7 samples here. This is 9 samples that fell between 15% and 20%. Said they had freshmen. Here we have 14 samples. So 47 samples out of the 50 total. I just kept thrown off by the typo. This should say proportion, P-R-O. The sample proportion falls between 0.1 and 0.35. So from 0.1 to 0.35, this is most of the samples out of 50. So because most of the samples are giving statistics of the proportion of freshmen being between 0.1, 10%, and 0.35, 35%, what we're being asked is who had a better result, Seth or Tia? So if we remember, Seth came up with a 20% of his sample were freshmen, so he was estimating 20% of the population were freshmen. Tia came up with 40% from her sample, and if you look at when we got more samples, we had more data to analyze and compare, Tia's estimate is actually outside of the range of most of the samples, most of the samples are between 10% and 35%. So we would say that that Seth's result is a better representation of the population. Tia's result is 40% way over here, and that's not most of what most of the samples were showing.